Let's look at some more related rates examples. Number 8, a particle moves along the curve y equals the square root of 1 plus x to the third. As it reaches the point 2, 3, the y coordinate is increasing at a rate of 4 centimeters per second. How fast is the x coordinate of the particle changing at that instant? Okay, no real picture to draw for this one. I don't know how to draw a particle moving along a curve. So we're going to go with what we have. We have our equation. Y equals square root of 1 plus x to the third. All right, we got that part. We have some information. We're told x is 2, y is 3, and dy dt is 4. So we have our equation and we have some basic information. Let's take our derivative and we'll go from there. I like to rewrite this. I don't like to have the square root notation, so I will rewrite it as the 1/2. When we take our derivative, the derivative of y, well, we're still looking at respect to time. So we have dy dt. Bring down our power, rewrite, subtract 1. Now we need to have our chain rule. So the derivative of 1 plus x to the third is 3x squared, and then don't forget dx dt. All right, which one are we trying to fill in? Which one are we trying to solve for? How fast is the x coordinate changing? Well, x coordinate changing, that's dx dt. That's what we want, and it's right here. So we need to get that dx dt by itself, and we need to substitute in all of the values that we are given for x, y, and dy dt. So let's start with substituting in our values. So dy dt is 4. We have 1/2. 1 plus x is 2 cubed to negative 1/2. Now we have 3 times 2 squared, and we're trying to find dx dt, so that one's just going to stay dx dt. So let's look at what we have here. We have 4, we have 1/2, we have the cube root, 8 plus 1 is 9. Excuse me, we have the square root of 9, and the negative square root, so that's going to be 1 over. And then we have, what else do we have? 2 squared is 4 times 3 is 12, and then dx dt. All right, let's rewrite some of this. So we'll have 4 equals 12 in the numerator, 2 square root 9 in the denominator, dx dt. So where did that come from? 12 in the numerator is right here, 1/2, 1/2. And then the negative 1/2 puts it as the square root in the denominator. Square root of 9 is 3. 3 times 2 is 6. So we get 12 over 6 dx dt. It's a funny looking 6. Let me fix that. 12 over 6 is going to give us 2. Divide both sides by 2. Looks like we'll get 2 is equal to dx dt. We should put a unit on there. So it looks like, do we have a unit? Nope, doesn't look like we have. Oh yeah, we do. Centimeters per second. There it is. It was hiding from us. There we go.